Hi everybody. In this video we're going to look at 3 different cases for when limits fail to exist. So what we want to do right now is consider the graph of this function, the absolute value of x divided by x. Have it graphed there. You can recreate this particular graph on Desmos or on your graphing calculator, however you prefer. But what's going on here is a couple things. On the left hand side you have this arm, but what this is saying right here, this is -1. No, that's actually -2, -1. So what that's saying is when x is equal to -2, you have is the absolute value of -2 is 2 over -2, and that's why you get -1. That'll work every time over here. This open circle here is remembering that the function is undefined when x equals 0, right? Because you can't, have 0 over 0. And then finally, what we have is on the right-hand side, we have this arm over here. So let's just take a look at this point right here, 1, 1. The absolute value of 1, of course, is 1. And then 1 is 1, of course. So we get +1. You get something like that anywhere you went on the right-hand side there. Now, let's get away from functions and into limits now and analyze what's happening around this thing. So we got this undefined notion. Let's look at what's going on here. And we actually have 2 things working simultaneously. First things first, we have a limit as x approaches 0 from the left. And we have this little notation, which is a superscript negative sign. And this is called a one-sided limit. This means this part right here, this is the limit as x approaches 0 from the left, right, from the negative side. So we're looking at what's going on here. And the output is always -1. So the limit is also -1 because the trend of what's going on around here is -1. Now, what's going on the right? Let's look at the limit as x approaches 0, superscript plus refers to this side. The limit as x approaches 0 from the right, from the positive direction. Let's look at this trend. And of course it's +1 because the outputs are always +1. No matter where you are here, the outputs are +1. But we have this disconnect here. From the left, we're approaching -1. From the right, we're at +1. So what's happening on both sides? Is there a consistent happening? Is there a consistent trend on both sides of 0? No, there is not. So going back to the original limit, the limit as x approaches 0, in this particular case, the limit does not exist. The limit does not exist because it is approaching a different value from each side. From the left, it approaches -1. From the right, it approaches +1. And this is known as a jump discontinuity. If you're evaluating this function for continuity, in other words, can you draw this function without picking your pen up? No, you cannot, because you have to jump from here to here in order to graph that thing. So that is one reason, that is one condition under which a limit will not exist. Let's analyze what's going on this one. So we have the limit as x approaches 0 of 1 over x squared. And hopefully your first thought was this fun word here, asymptote. Because what we have is we have a vertical asymptote. The y-axis in this particular case acts as a vertical asymptote. The closer you get to 0 from either direction, the farther and farther up to infinity that this thing approaches. This is called unbounded behavior. So there is no value that you can assign y as x approaches 0 from either side. This is once again a condition where the limit does not exist. All right. The limit does not exist. There is a vertical asymptote. The function increases without bound. And the big fancy term for this is an essential discontinuity. So that is the second condition under which limits don't exist. The third condition under which limits do not exist, is something like this, the sine of 1 over x as x approaches 0. What you can see is this thing goes absolutely haywire around the origin here. And how many times does it bounce back and forth between -1? It's kind of wild. It actually oscillates infinitely. In other words, the more you zoom in, the more oscillations you can witness. So when you approach 0 from the left and from the right, you cannot assign a value to the y, to the output. There's no one value that the output is approaching, because it bounces back and forth so rapidly between -1 and +1 that in this particular case, again, the limit does not exist. And that is the third and final condition under which a limit does not exist. And that is due to this oscillation. The word oscillation means bouncing back and forth, like a fan. An oscillating fan, rolls back and forth. So what you can do is jot down this little guide. There are 3 conditions under which limits fail to exist. You have a jump discontinuity, when you're approaching different values from each side. One value from the left, one value from the right. You have an essential discontinuity when you have a vertical asymptote. And you have oscillating between 2 fixed values as x approaches c.